Angular and linear velocity. So angular velocity, if a point is in motion on a circle through the angle of alpha radians in time t, then it's an angular velocity. Okay, angular velocity. So linear velocity is if a point is in motion on the circle of a radius r through an angle of alpha radians in time t, then it's a linear velocity. Okay, so we are given these formulas. Our angular velocity is going to be omega equals alpha over t, so time. The linear velocity is our velocity is equal to our s over t, our surface, or also called our arc length, and which it has a formula as well. S is equal to alpha times r. R is my radius. So a linear velocity in terms of angular velocity. If velocity is a linear velocity of a point on a circle of radius r, then the omega is an angular velocity. Then we have a velocity is equal to radius times the omega. So let's solve. So on this first one, we're going to find the product included. Well, this is set up for you. This is something we need to know. We need to know for every 1 revolutions, it's equal to 2 pi, which is radians, which makes sense. 1 revolution is 1 complete circle, right? And at the end of the circle is 2 pi. We also know that there is 60 minutes in an hour. So the way it's set up is where the radians reduce, the minutes reduce, and it leaves me with revolutions per hour, which makes sense. So what we need to do first is say 13 times 1 times that 60, and it's all going to be divided by 1 times 2 pi times 1. And we don't forget it's revolutions per hour. So what do I have? I have 13 times 60, and it gives me 780 revolutions. When I do 2 pi, make sure in your calculator, you might have to use the shift button or the mode. It's going to give me 6.283185307. I try my best not to round because if we round too early in the middle of this process, our answer can be off by hundreds or tenths or even a thousandths of a point. Okay, so now I'm going to divide that 780 by the 6.283185307, and let's round it to the nearest hundreds. And I get 124.14 revolutions per hour. Okay, so let's do the next one. Well, the next one says perform the operation that we have here. What they want is we got revolutions per minute and we want to go to radians per minute. So it's already in minutes, so that's not going to be our problem. What we got to do though is take it out of revolutions. So what do I know? Well, we got it written right here. For every 1 revolutions, it's equal to 2 pi radians. So if I take this and set this up, I would set it up where my revolutions were reduced, right? So that means it needs to be on bottom and that 2 pi needs to be on top. And it gives me my radians, my revolutions reduce. And now I'm left with, and I should have rewrote this over here because this would exclude this equal sign right here, right now, because of how we got it set up. Give me 35 times the 2 pi radians over minutes, because it's just 1 here. And if you want to write the 1 there for now, you can. So now 35 times 2 pi is going to be 219.9 radians per minute. And that is my answer. Not bad, right? All right, so let's do the next one. The next one says that we have 720 revolutions per hour, and we want to go to revolutions per minute. So now here we're not only going to do the revolutions per 2 pi radians, we're going to have to do for every 1 hour 60 minutes because we got to convert that there. So that's something else we know. So let's rewrite it. Let's say 720 revolutions over 1 hour. I'm going to go ahead and do the hours. Let's reduce it to 60 minutes. That's something we already know. And it's in revolutions, and that's what we wanted. So, we don't have to add another conversion. It worked out great. Let's go ahead and reduce the hours though. And let's do the 720 divided by 60. And always reduce your answer, always, always. And this just so happens to reduce nice and pretty. All right. So let's look at the next one, and I apologize. I didn't give myself a lot of room to write on here. So on this next one, the 140 revolutions per second, we're going to go to radians per hour. And so we're going to have to do some work. Let me just draw a line here. And let's see if I can separate and give myself some space here. All right. So I'm going to take that 140 revolutions per second, and I'm going to plug in what I know. And some of you are going to do, you could do, there's 2 ways to do it. One, we could say for every 1 minute, it's 60 seconds. You could do that. Or you can say, all right, we know that there's 60 seconds in an hour, and that's 24 hours in a day. Then that's how many seconds times 60. You could do that, or we could just stay with this here. You gotta be careful. There's more than one way to set this up, but let's just stay with let's keep it simple, okay? So I am going from seconds to minutes, minutes to hours. Again, what I was gonna say is how many seconds are in an hour, right? So we know there's 60 seconds in a minute, right? 60 times 60 is 3,600 seconds in 1 hour. That's what I meant to say. So you could use either one of these conversions. If you use this one here, you're going to have to add in the simple fact there's 60 minutes in 1 hour. I'm getting tongue-tied here, apologize. So you can use this one, or you can use this one. It doesn't matter. I'm going to use this one because I'm going to keep it as simple as possible. Remember, we want the seconds to go away, so they need to be on top. We need to be able to reduce it. See it? It reduced. That's what we wanted. All right, so now I got revolutions per hour, and we want radians per hour. So let's add one more needed conversion. We know for every 2 pi radians, that is 1 revolution. Okay, so can we mark the revolutions out? Yes, and left me with radians over hour. That's exactly what we wanted. So now I'm just going to multiply the 140 times 3,600 times 2 pi, all divided by 1. That was perfect. And I'm going to round to the nearest tenths, and I get 3,166,752. I am tongue-tied. My apologies, guys. 725.4 radians per hour. So that is my answer for this one. So keep it simple. You could use either one of these setups. As long as your setup and your math is correct, your answer would be the same. So we got 2 more to solve. Let's solve this next one. This one's talking about the angular velocity. So we're going to use the formula, and we're going to solve for our angular velocity, which is called our W, which is omega. All right, it says a windmill for generating electricity has a blade that is 40 feet long. Depending on the wind, it rotates at a various velocity. Find the angular velocity in radians per second for the tip of the blade if the windmill is rotating at a rate of 29,724 revolutions per day. All right, so let's set this up. my angular velocity. And we are given the 29,724 revolutions. We know it's in a day. It says they want us to solve it in radians per second. So we got some work to do here. I know that in 1 revolutions is 2 pi radians. All right, I already got that part done. Let's mark out the revolutions. Yay. Now we need to get day converted to seconds. Well, what I know, in 1 day, there's 24 hours. And I know in 1 hour is 3,600 seconds. All right, now let's mark out, reduce what we can. And what are we left with? Radians per second. We did this right. So now we're going to multiply the 29,724 by 2 pi by 1 by 1. And then we'll divide it all by 24 times 3,600. And that's we're going to round to the nearest tenth, and it's going to give me 2.2 radians per second. So multiply straight across first, get an answer, multiply by the bottom, get an answer, then divide them. All right, let's do the very last one. So the blade, let me get another sheet here. All right, the blade on a typical table saw rotates 30 50 is what I was going to say, 3,050 revolutions per minute. And calculate the linear velocity in miles per hour. So we're solving for miles per hour. Again, we got 3,050 revolutions per minute of one of the teeth at the edge of the 10-inch diameter blade. All right. So remember our formula that we're going to be working with, this little s equals alpha r, radius. So alpha is going to be my central angle and r is my radius. So let's complete, when you complete 1 complete revelations, we know that that is equal to 2 pi, and we know it's radians. Since the diameter is 10 inches, the radius of the blade is, okay? So to find the radius, we know radius is half of a diameter, right? We know this, so we divide it. Well, if the diameter is 10 inches, then that means we need to divide it by 2 in order to know what my radius is. So my radius is 5 inches. So we know that. So now we are talking about terms of pi. The arc length of the revelation is going to be, right? We got 5 for the radius and we got 10 for the diameter. So now I know that the arc length, it's going to be that 10 plus 5, which gives me my 15 pi. All right, moving on. Now let's solve for it. This is just some side notes. Let's actually solve for what we're looking for. We got the 3,050 revelations per minute. And we know that for 1 mile, it is 63360 inches. And we know 60 minutes is in 1 hour. And when I do this, now I have, round to the nearest tenth, I have 90.7 miles per hour. And that is the answer to my question. This was some extra side work. Really didn't need it. Sometimes it asks, but it's important that you actually know how to find the radius if you're given a diameter. So this part here is important. And this is our answer.